Okay, so to continue on, we're going to be on page 3 of your notes for Unit 7, which is all about similar figures. So by definition, the symbol for similar looks like a little squiggle. It's kind of like the top of what a congruent sign looks like. It's just this part right here. So by definition, figures are similar, so two or more figures that have congruent corresponding angles and proportional sides. So the thing about similar figures is that the angles are the same, but the sides are not. So let me go ahead and grab some binder clips to kind of have this make a little bit more sense. So here's one binder clip and here's another binder clip. These binder clips are similar. So what happens is the angle that's right here in this corner is the same as this angle over here. These angles don't change, but their side measurements change at the same rate. So the sides are proportional. So congruent means equal. So for example, these two binder clips are congruent. They're the same shape and size. But these two binder clips are similar to each other. They're the same type of shape, but different in size. So to help you figure out which angles are the same, you have to use the similarity statement. So up top, notice how it says triangle ABR is similar to triangle XWK. The way you match your angles is based on how it's ordered. So A is first and X is first. That means angle A and angle X are the same. So when we're listing some congruent angles here, angle A is congruent to angle X. They're both the same. And you're just going to continue this pattern for the rest of them. So B is listed second and W is second. So B and W are the same. Now the reason that you want to make sure that you match the angles is because when you solve problems involving proportions, if you match the sides incorrectly, it's not going to give you the right answer. Like, you're going to solve it wrong. So you have to know what sides correspond to what. So here and here, so R and K. So when you're solving problems involving proportions, you have to be able to match the congruent angles. So notice how we put A, B, and R first. That's the first triangle over here. Then we put X, W, and K second, which is the second triangle here. So keep everything in order. And the way that we are going to match our sides, so sides are proportional, the way that we're going to match our sides is kind of based on the angles. So A to R, side AR, corresponds to the side that matches the angle colors. So yellow, orange, yellow to orange, X to K. And then we're just going to continue. So now I'm going to pick another side. Here's side AB. And notice how I'm not marking them congruent. I'm just matching them because they're not the same measure. They just correspond to each other. When you're matching, you want to make sure to start at the same angle in the second triangle that you started in the first triangle. So I started at yellow, which means I start at yellow here. So X goes to W. And then by default, BR corresponds to WK. Okay. Now what this is called an extended proportion. So this here is called an extended proportion. We talked about extended ratios on page 1. An extended proportion just compares 3 or more ratios. Okay. Also notice how we kept the first triangle on the top and we kept the second triangle sides on the bottom. So it's all about consistency. So let's try to solve some problems. So we want to know what the value of X is, and all it tells you is that triangle JKL is similar to triangle QRS. So what you're going to do is match the angles. J and Q are first, which means J corresponds to Q. It's all about angle matching. K is in the middle, and so is R. So K corresponds to R. And last we have L and we have S. L and S. Okay? Now we can start matching our sides up to make our proportions. So it's all about matching proportions. So I'm going to start with, let's see, this side, x plus 4. Well, that is between yellow and orange. So yellow and orange over here is x. So this side goes with this side. So I'm going to put this one on top, and then I'm going to put the x on the bottom. And then you're going to just follow that same pattern. It's all about pattern, okay? So now I need to go back to my original triangle, which was 9, which is between yellow and pink. So yellow and pink over here is 3. So 9 corresponds to 3, which means 9 will be in the numerator and 3 will be in the denominator. To solve from here, you just cross multiply. So this would be 3 times x plus 4, and make sure that since it's a binomial that you're putting it in parentheses so you distribute. So 3 times x is 3x plus 12 equals 9x. So I'm going to subtract 3x to the other side and continue the problem up here. So this becomes 12 equals 6x. And when I divide by 6, I get a value of 2. And that is the measure of our variable. So things to remember, just make sure you're starting at the same triangle. Notice how these are both from the same triangle and they're both in the top. Number 2 is all about overlapping triangles. This is a little bit harder. What I would recommend is paying attention to the triangles individually. So here's our first triangle. Okay, triangle ABE. So I'm going to draw, I guess I should probably trace that. So here's triangle ABE. We got 5x and 10. And I'm going to draw it the same way so we don't have to worry about angle matching. Now we've got this bigger triangle. Okay, we've got a bigger triangle, which is here. Okay. So to help us with the larger triangle, we're going to have to do a little addition. So notice in this problem, we need to know this full length. In order to find the full length of AC, you're going to add 12 and 5 together, which is 17. So this measure is 17. The full bottom is 19. And then this 10 really doesn't have a place because it's not the full measurement. So now we're going to set up our proportion. These are drawn the same direction, so we don't need to worry about angle matching too much. So we know that 5, grab a little pen, 5 is going to correspond to 17. So this becomes 5 over 17. And then to draw the rest of our proportion, we have to go in the same direction as we did. So I'm going to go back to my first triangle. The side x corresponds to 19. So this becomes x over 19. It's all about patterns. Then I'm going to cross multiply. So 5 times 19 is 95, and that's going to equal 17x. When I divide by 17, we get a decimal of 5.6. So similar figures, in order to set them up, it's all about just matching sides and making sure everything corresponds. The very last thing we're going to talk about is the 3 similar triangle theorems. So kind of like with congruent figures, you have side, 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 angle, side. This is only for similar triangles. So we're going to focus on angle, angle similarity first. We're going to write it in words and then talk about what it means. So in words, the statement says if 2 pairs of corresponding angles are congruent, then the triangles are similar. So what that means is in our picture, notice how A has one curve and A prime has another. That is one pair of congruent angles. So angle A is congruent to angle A prime. Okay? That little tick mark is called prime. Okay? Then you're going to do the exact same thing with B. Notice how B has 2 curves, B prime has 2 curves. That is the second angle pair. So angle B is congruent to angle B prime. I've got two angles that are the same, so those triangles are similar. Because by default, C and C prime must also be the same because every triangle adds up to 180. Number 2 is side, side, side similarity, and this is all about ratios of side lengths. So in this problem, by definition, we're going to do that first. It says if 3 pairs of corresponding sides are proportional, then the triangles are similar. And I'm using the symbol for similar. So the way that you match these up is look at your picture, and looking at your picture, notice how 10 is the smallest side measurement on the first triangle. That means that it would correspond to the smallest side on the second triangle, which is 5. So what you're going to do is make a fraction. So you would do like 10, I'm going to start with the first triangle on top, so 10 over 5, and that reduces to 2. In order for the triangles to all be similar, every single side pair must reduce to the number 2. Then I'm going to go up, so 15 is my next largest side, and my next largest side here is 7.5. So I'm now going to do 15. I'm keeping with the pattern of the first triangle on top, and I'm going to divide that by 7.5, and I also get 2. And then you have to make sure that all 3 are the same. So 20 is the largest on the first triangle, and 10 is the largest on the second. So I'm going to do 20 divided by 10, because I'm keeping triangle number 1, the first one, on top. And notice how they all reduce to 2. That lets you know that the triangles are similar. If one of them had reduced to a different number other than 2, they would not be similar, and they wouldn't be similar by side, side, side. The very last one is a mixture of side, 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 and angle, angle. So we're going to do words first. If 2 pairs of corresponding sides are proportional, and the included angle, and the term included means between. So, and the included angle, or angles, there's 2, are congruent, and that's the symbol for congruent, equal sign with a squiggle. We learned that in the geometry unit. Then the triangles are similar. So, to do this one, I'm going to start with the side first. So I'm going to start with 7, which is the smaller of the 2, so that should correspond to 14, which is the smaller of the 2 on the second triangle. So I'm going to do 7 over 14, and that will reduce to 1/2. Next, I'm going to look for my angle, my included angle. So in my picture, A and P correspond together. Well, A and P are congruent, so I'm going to put that here. So angle A is congruent to angle P. Next, I should go to a side. So the angle is between the sides. So my last side on the first triangle is 9 with 18. So now I'm going to do 9 over 18, keeping with the pattern, and I also get 1/2. Notice how the sides reduce to the same number, and the angles that are between those sides, which is why I wrote it this way, the angle between the 2 sides are congruent, so by side, angle, side, the triangles are similar.